Hello everyone, we are Group 15. I'm Zhang Shiyu.
I'm Colin.
I'm Wenqing.
Today, we merely introduce a paper from BatDance AI Lab, constructive learning from many-to-many multilingual neural machine translation. There are two main challenges in machine translation. First of all, the traditional translation is a single model, such as English to French. However, there are more than 6,900 human languages in the world. In other words, if we want to complete the work of translation from one language to another language, we need millions of single models, which is obviously impossible. Secondly, even if we really have so many resources, the existing data does not support us to do so. The amount of data in different pairs varies greatly. For example, Britain and French have a lot of data resource, where the Yoruba and Sindhi has very little parallel. Therefore, we want to support many-to-many translation through the training of the multilingual model. Of course, multilingual machine translation was studied 5 years ago. Even the current multilingual machine translation is based on the supervised scenarios. Although multilingual machine translation naturally supports zero-shot translation, its efforts is poor. If we use the bridge model as a reference, it's much weaker than the bridge model. Sometimes it's not even available. Secondly, the effort of multi-language machine translation is a high resource direction is worse than the traditional machine translation. If we use a model contains many of languages for translation, the efforts will be worse than a single model trained in only 2 languages. Third, the current multilingual model merely uses parallel data for training, but the amount of the parallel data is far less than the parallel corpus.
Therefore, the purpose of this work is to build a multilingual translation model, which can support supervised, unsupervised, and zero-shot translation at the same time, and can achieve the same result as a single model in the high resource direction. In addition, monolingual data can be used to improve the effect of the model. This work proposed a model called MRASP2. Firstly, it is a unified multilingual translation model and is also a ready-to-use model. We are based on the assumption that sentences with the same semantics across different languages should have similar representations, as shown in the slide. A line argument is a main method in MRASP2. Before this work, there is another work about MRASP, which is to replace the words of one language with synonyms of another language in the course. For example, English, here it's replaced with Chinese. MRASP2 is to replace the word of original text with synonyms in multi-languages, such as replacing Chinese with English, French, German, and Arabic. Next is the training framework of MRASP2. In addition to the original cross-entropy loss, their work with also add a contrastive loss. The occur and the positive is the parallel sentence in different languages, and the negative is the rest and parallel sentence in the different language in the batch. There are many negatives, and the loss computes the sum. The purpose is to minimize the representation gap of similar sentence and maximize of the irrelevant sentence. Finally, the total loss is the sum of the 2 losses, and its formula is shown in the slide.
Okay, next, let's consider 2 questions. And the first one is, does MRASP2 work on supervised or unsupervised or zero-shot scenarios. And the second one is why MRESP2 works. Then let's introduce the data sets. The first part is parallel corpus, and the second part is monolingual corpus. Except the 21 language in PC32, Dutch, Polish, and Portuguese are also added. In addition, temperature sampling is added to country distribution. The next is the experimental results. The first is the direction of supervision. The red bar is the result of MRESP2, and we can see that MRESP2 has achieved relatively good experimental results in these 10 directions. And the second is the unsupervised direction. We have previously added three language in the dataset, but MRESP2 has still achieved good results in the translation between English and these three languages. Moreover, when the source and the target and only exist in monolingual data, although the performance of MRESP2 is very normal, but the effect has been unexpected. The last is the zero-shot direction. The blue bar represents the bridging model, which is a very powerful model, but MRESP2 can achieve the same result. And next, let's consider the second question, why MRESP2 works. Our answer is better semantic alignment. From the experimental data compared with the transformer, and the addition of aligned argumentation and contrastive learning can increase by about 6 percentage points respectively. Okay, to sum up, MRESP2 is a universal multilingual MT model, and it leverages monolingual data along with parallel data in a unified framework. Also, it bridges the representation gap of utterance in different languages with the same semantics. Okay, thanks for your attention.